Please write both an explicit equation and a recursive equation for the sequence given here. So one of the things I notice is that this particular sequence is arithmetic. First term is 5, I jump to 8, jump to 11. So each time I'm adding 3. So we call that our generator, right? Generator. Each time we're adding 3 to get to subsequent terms. If I wanted to write the explicit rule, I need to know what the 0th term is, right? That's not something we list in the sequence, but 0th, I don't know if there should be an E in there. Probably is. 0th term. Let me write the word term. So if I look at this, the first term is 5, and if I'm adding 3 to go forward, that means the 0th term would have to be the number 2. And that's pretty important when I am writing the explicit rule. In fact, I can write the explicit rule now. It is that any term, right, you give me the n and I'll tell you the value of the term, is equal to 3 times the term number that you give me plus 2 more. And you can see this works for term, for example, this is term 1, 2, 3, 4, 5. If I put in, for example, 5 into this explicit rule, right, if 5 is n, there's a 5 there. What do I have? 3 times 5 is 15 plus 2 more is 17. So any of these values, you give me the term number and I'll tell you what the particular value is at that point. Okay, so now let's go ahead and this is the explicit rule. Let me clean this. I'll get rid of this for now, and let's write this down. I'm going to bring this down a little bit and go ahead and write explicit. So the other thing that we have is, of course, the recursive rule. So let's write that right here. And the recursive rule needs two things, right? It needs to know where the sequence starts, and it needs to know how do you get to subsequent terms. Basically, what's the relationship from one term to the next. So this sequence starts at 1, so I would say, hey, t at the value of 1. I'm sorry, it doesn't start at 1. Yes, it's the first term, but t at 1 is equal to 5. That's this value right here. The first term is 5. And you can see what I'm doing is, and this is how I read this again, is the next term, right? The next term in a sequence is equal to the term that you're currently at. And that's what t of n represents, the value of the term you're currently at, plus 3 more. So together, those two statements comprise the recursive rule, right? Where we start and how we go from one to the next, to the next, to the next. So you can see, for example, if I'm starting at 5, to go to the next, it says the next is just 3 more than what you're at. So 5 plus 3 is 8. And the next after that is 8 plus 3 is 11. And the next after that, 11 plus 3 is 14. So there's both the explicit and the recursive equations for this sequence.